Hi guys, today we will be talking about Boyer-Moore's algorithm, also known as majority voting algorithm. Let's quickly check our agenda. Firstly, we will be understanding the problem statement. We will be looking the brute force approach of that problem. We will optimize it using Boyer-Moore's algorithm and other algorithms also. And the last, we will be discussing a variation of that same problem. Let's quickly jump on to the problem statement. So the problem name is majority element. It is on LeetCode. So what is the problem? Let's see. Given an array nums of size n, we are given with an array of integers and we have to return the majority element. So what is the condition of that majority element? The majority element is the element that appears more than n by 2 times. You may assume that the majority element always exists in the array. So if I take an array, suppose let's take this array only, the second example. So you can see the size of this array is 3 plus 3 7. So what will be n by 2 of 7? The n by 2, the integer division would be 3, right? So whichever element which appears more than 3 times in this array will be our majority element. You can see 2 appears 1, 2, 3 and 4, 4 times. So 2 will be our majority element. That will be our output. So what does the problem say? Suppose we have an array which is 1, 2, 4, 1, 2, 1, 1. Now if you see what is the size? Size is 7. We have to find the majority element. So what is the condition of the majority element? The occurrence of that element has to be greater than size divided by 2. So this is the condition. If we check what is the occurrence of 1 over here, so it has appeared for like 1, 2, 3, 4, 4 times, right? So 1 has occurred 4 times. 4. What is the other element? 2. 2 has occurred how many times? 2 times. 4 has occurred just 1 time, right? So if you will see, what will be size by 2 over here? Size is 7. 7 by 2, what is 7 by 2? 3. And we will be always taking integer division over here. Or you can say the floor value of the division. So we can see only one element exists, which is more than 3. That is 1. So we're going to return 1 over here. Let's discuss the brute force approach of this problem. So what could be the brute force approach that comes into your mind when you see? So what we can do is we can select an element and then we will traverse the whole array to find the count of that element. And then we can do this thing for every other element. So I will directly explain you the code of it. So the outer loop is for the ith element which we have to traverse. This will be the loop of that. We will initialize a count that will store the count of that first element which we are talking about. We will check if the particular element is equals to the element which we want to search. We will just increase that particular count, and after this loop will end, we will just check if that count is greater divided by 2. We will just return it, right? So that is the simple brute force approach. What do you think will be the time complexity? Since we are using two loops over here which are going up till the num size, the time complexity would be O of n square, which is definitely not a good one. If you will give this solution to an interviewer, he won't be happy, definitely, because you have to do a bit better than that, right? So after this, what do you think could be the more optimized solution? We already saw the n square solution. So the better optimized would be something of like O of n log n or maybe O of n. So we will discuss about the O n log n solution, and then we can go on to the final optimized solution, which is O of n. So if I run this, it will run successfully, but then definitely it is of O n square complexity. It's gonna give you TLE later. So let's discuss what could be the better approach than this. So whenever you see an integer elements and you have to deal with the occurrences, what comes to your mind first? To me, it comes like hashing them. We can hash the number of occurrences and then we can loop over that hash data structure, whatever we are using, a vector or an map. So what we can do is we can store the occurrences of these integer elements in that map, and then we can loop over that map to know which element has occurred more than n by 2 times. What could be the time complexity of it? So time complexity will be n times. Let me show you the code for it. Okay, so this is the code when we will use map. So what we are doing is we are looping over these elements, and we are storing the occurrences into the map by using this statement, and then we are looping in the map. So whichever element has the second property greater than size divided by 2, we will just simply return it. We are using return -1 if there is no majority element, but it is said over here that there will always be a majority element, but just we are considering that in other questions you might have to return -1. Now if I will run it, it's still gonna accept it, but then we can do still better than that. Let's quickly see what is the time complexity and space complexity over here. So this for loop will run for like n times, and then to access the elements we will be using O of n log n. We can use unordered map to reduce it, but the worst case of unordered map is also n log n. So overall time complexity would be n log n. And also we are using map, so our space complexity has also been increased. Now, how do you think you can decrease the space complexity over here? I will tell you a simple solution for it. So what we can do is we can sort this number. Now, did you observe something? That the majority element will always be a single element. There cannot be more than one majority element. For example, if I have to explain that thing, let's take this array over here. All right. So what we can do is we will sort it. It will be 1, 1, 1, 1, right? So this will be the sorted array. Can you see one thing? That the majority element will always be at the center. It will always, no matter what is the array, the majority element will always occur at the center. See, like imagine it this way. What is the majority element? It has to be more than n by 2 times. What is n? Suppose n is, let's say 10. 10 by 2 is 5. So it has to appear more than 5 times. You getting it? So if it is more than 5 times, it has to be the minimum of 6 at least. If it is 6 times appearing, it will always be occurring at the center, at the middle of the array. So what you can do is you can just sort this given array, and then you can just return the center of that array, right? So that would give you majority element. So now what is the time complexity of doing that? Sorting will take you same n log n times, but now we are not using any extra space. So our space complexity has reduced. But the catch over here is that for this solution to work, there should be this, that the majority element has always to occur. But if there is no majority element, this solution, by sorting it, is going to give you a wrong answer. So this is the sorting code. It is pretty much simple, 3 lines only. We are just sorting this array, storing the num size, and just we are returning the middle index. If I'm going to run this thing, yeah, you can see. Let's jump on to the most optimized solution. So to understand the Boyer-Muir's algorithm, I'm going to dry run this code over this example so that it will be more clear for you to understand how this algorithm works. For this algorithm, we will be needing two variables, x and count. So what x will be denoting is, it will be denoting the majority element. So we will be starting with x equals to the first element. So that will be our hypothesis, that one is the majority element, and so on. What count will do is, count doesn't store here the occurrence of this majority element. It has some other significance, which I'm going to tell you. Let me write the size of it. It is 3, 3, 6, 3, 9, 10. Now let's try run this thing. Our element will be 1 for the first time. Now if number denotes this, if the number is equals to x, x doesn't have anything right now, so definitely this will fall. It will come into else if. Now if the count is equals to 0, we have to initialize the num to x and count to 1. Let me take these things over here. Num is not defined right now and count has 0 value, so it will go into the else if case. Now if count is 0, 0, count is equals to 0, we will be initializing x with num. It has to be x, right? So x will be num. What is num? So x will become 1 and count will become also 1. Let's initialize count with 1. We have traversed this thing. Let's go on to the next element. Now if num is equals to f, if this 1 is equals to x, yes it is, what we will do, we will increment our count. Count will become 2. Now we have traversed these two elements, right? Up till here, suppose if this was an array of 2, alright, if this was an array of 2 elements. 1 would be the majority element because it is exceeding this condition, which has to be size divided by 2. It is more than 1, it is for 2 times, so 1 is the majority element. So up till now we have the hypothesis that x will store the majority element. It is correct till now. Let's go to index 2. Is num equals to x? Num is 2, x is 1. No, it is not. It will go in else. Is count equals to 0? No, this is also wrong. Let's move forward. It will apply this else condition. Count minus minus. Let's decrement the count. Let's go to another value. 3. Now, is num equals to x? Is 3 equals to 1? No. Is count equals to 0? No. Count minus minus. Count equals to 0. Now, this is the most important part. Whenever count hits 0, what you have to do, if you see the second condition, you have to initialize this x with the num variable. This one. When we will be looping again, we will be looping over this 2 and the count will be 0. We are initializing x with this variable. So when we are taking a new majority element as an hypothesis, and also we are again initializing the count with 1. What does this mean? What does this signify when count equals to? Okay, suppose we have just this array with these 4 elements. Now, if you see clearly, there is no majority element. 1 can never be a majority element because it is not eligible. For the 1 to be majority element, it has to be more than the n by 2. N is 4, 4 by 2 is 2, so it has to be more than 2. Right now it is just 2, so 1 cannot be our majority element, right? So did you observe something? For something to have a majority element, it has to be an extra 1. If there was triple 1 over here, then it could be a majority element. That is not the case. Suppose if this was the case, was this, that would be a majority element. But if there was 1 over here, our count would never have been 0. Count will only be decremented when there is different element. Suppose count increase by 1, 2, 3, and count will decrease with just 1, which will be count equals to 2. So we know 1 is our majority element. So now you know what this count signifies. So this array is done. We don't have any majority element up till this array. Now we are at this element, right? So let's traverse this. Is num equals to x? No, it is not. 2 is not equal to x. But is our count equals to 0 now? Yes, it is. What we are doing is we are initializing x with num. X will become 2 here and count will become 1. Because now let's traverse the second element, which is again 2. Is num equals to x? Yes, it is. Let's increase our count. Let's move on. 1. Now, is num equals to x? No, it is not. Is our count 0? No, it is not. This condition will happen. So our count will decrease 1. Fourth element of this particular array is this 1. So is this equals to x? No. Is our count 0? No. Let's decrement it. So you see, this is the same thing which happened with this array. Here we thought our majority element is 2. We consider it in our hypothesis. But in this array, for the majority element to be 2, it has to appear more than 2 times. But it is appearing just 2 times, so it is not the majority element, right? So this has been traversed, right? Now we are on this element. Is our num equals to x? No, it is not. But is our count equals to 0? Yes, it is. What we are doing? We are just doing x with num, and also count is 1. Let's traverse this thing. For this it is equal, so just count will be 2. Now our whole arrays process, we have x value equals to 1, right? But we don't still know that is x our majority element or not. But if our majority element exists in this whole array, it will be 1. But if it doesn't exist, we have to return -1. How do we know that? Now here we can see clearly that 1 is appearing more than like 5 times. 1, 2, 3, 4, 5, 6. So 1 is our majority element and we also have it here. But what if the value was something like this? Now it is appearing just 5 times. So 1 is not our majority element in this case. How we will tackle that thing? In our this question, LeetCode question, we already know that the majority element will always exist. What if the case it will not exist and we have to return -1? When we will traverse, we will be left with x equals to 1 over here, but that is not our majority element. We have to return -1 in this case. What we can do is we can again loop over this whole array and then we can check the count of 1. So if our count becomes greater than the size divided by 2, we can return that x, else return -1. So suppose here our x becomes 1, we will check how many times x has 1 has appeared. So it will appears like 6 times. We will check the count of it. So it will satisfy our condition. We will be returning x, that is 1. What if 6 was there? When we will check over here again, we will get our count to be 5, which is not greater than nums dot size divided by 2. In that case, we will be returning -1. So this is the code. Let me quickly run this. Let's submit this. You can see it is accepted. Let's discuss the variation of it. Okay, so this is the question, which is the variation of our previous question. So given an integer array of size n, find all elements that appear more than n by 3 times. The only difference between these two is that it has to be more than n by 2 times. Here it has to be more than n by 3 times. Now, what do you think? How many majority elements can be there if it has to appear more than n by 3 times? For n by 2 times, you know there will always be one element. So let's take the example. Let's take the same example, this one. Right. Let's change it back to 1. What is the size over here is 10. Okay. For this condition, the majority element has to be more than 10 by 3, right? What do you think? How many majority elements can be there? Let's see. What is the integer division of 10 by 3? Which is 3, right? So it has to occur more than 3 times. Let's see. If an element in an array, let's initialize the starting with 4 because it has to be more than 3 times, right? So it has to be at the minimum of 4. Let's take another element, 2, 2, 2, 2, right? So in this condition, 1 is a majority element because it is occurring more than 3 times. 2 is also a majority element because it is occurring more than 3 times. How many spaces we are left with? We are done with 8 elements. Let's assign maybe 3, 3. So you observe this thing that there cannot be more than 2 elements. 2 is the maximum. Either it can be 0, either it can be 1, or either it can be 2 majority elements in the condition where the occurrence of the majority elements should be more than 10 by 3, size by 3. So there will be maximum of 2 elements. You take any condition, you take any array, it will always be maximum with 2 elements. Okay, so our this code, let's copy this code. Let's edit this code only to make the other code. It will be more easier for you to understand. So we are just taking one variable. Let's take another variable into y. Let's initialize this count 1. Let's count 2, which is 0 again. Now, when we are iterating, we are checking if number is equals to x. But we also have to check for the second number. Now, if number is equals to y, here we were increasing count to 1. Here we have to increase count 2. And similar in this condition also. Else if, now if our count 2 becomes 0, y has to be num and count 2 also has to be 1. This will be count 1, or over here also count 1. Now in this case, count 1 also decrease and count 2 also will decrease. Let's reinitialize them with 0 to check if those are the majority elements or not. Over here, if our num is equals to x, we are increasing count to 1. If our num is equals to y, count 2 will increase over here. So in this question, we have to return these two elements in a vector, right? Let's initialize a vector. Okay. So rather than returning over here, let's just push. Here we have to do x, y, it has to be less than this thing, and then we will be just returning this answer. Let's see if this works or not. Let's submit this. Okay, so it is accepted. Now, what do you think will be the time complexity over here? We are running this loop. This is on. Are we using an extra space? Hardly any space. These four variables will be equal to like O of 4, which is equals to constant. So O of n over here, again O of n, which is O of 2n, and also here we are using an extra space answer, but then it will be just storing two elements, so it is negligible. We can treat it as constant. Now you know what is Boyer-Morse algorithm. So comment down if you have any issues, if you have any doubts regarding this algorithm, or if you need any code, I will pin it down to the comment. Thank you so much for watching. Have a good day.